All right. Hi, everyone. Thanks for coming to the second Fission Reactor call. These are monthly. Last month, we kicked things off with mostly an information dump on everything that we've been up to and doing. But really, the core idea here is to start discussion and talk about what Quinn and I are thinking about lately, and also solicit just general feedback from people that are interested in these things. So I'll let Quinn talk a little bit about what's been on our minds. We have one of our internal posts that we're going to share about the remaining open sort of theory questions. But we feel like we've tied off most of like the really big hairy things, which is good. And then, yeah, we'll open it up to general discussion. So Quinn, what have you been thinking about?
Yeah, so thanks everyone for joining. Like Brooklyn said, the structure of this call is going to be a little bit different from last time. We don't have a big presentation or anything to share with you today, and this is mostly going to be a discussion. We are at this point just about ready to start the initial prototype for Dialogue. Currently, the plan is going to be to do an MVP in Elixir. Once we prove that all the ideas work, pass that off to some of the team that's been working on our web native stuff to do a REST implementation. And really the last big piece before we're ready to start doing that POC is figuring out some of the incremental view maintenance stuff that we touched upon last week when we were talking about data log. So for those of you who weren't here or need a refresher, the idea here is basically to use data log to basically query a view over the database that you're reading from, and to do so in a way allows you to incrementally update that view as either new facts are added or deleted. So in response to pulling new information from the data sources that you're reading from, or as you are moving throughout your own like personal timeline over the data to see what it looked like at an earlier point in history, for example. And last time I had mentioned that where we were leaning was making use of what is called the delete read arrive algorithm, which at a high level basically works by taking in some delta over the data that you would like to materialize the view over from like the previous state to the new state that you're materializing. And then basically running in three different stages. First, you do this delete phase where you are deleting all of the derivations or all of the pieces of that view that depend on the data that's being removed in your delta. And that's always going to be an overestimate. Then you follow up by doing what's called the read arrived phase, where you essentially walk over your view or your data log program and find all of the pieces of that view that can be read arrived using other data that you have access to. And then lastly, those read derivations just get reinserted into your materialized view. And the hope is basically that this will allow you to efficiently walk across your timeline and add and remove facts without needing to recompute the entire state from scratch every time. Alongside a bunch of conference speaking that Brooklyn and I have been doing, one of our big focuses since last time has been ironing out a lot of the details about how we would really like to deploy delete read arrive. And in particular, something that we've been thinking a lot about is how it interacts with some of the use cases that we have in mind for dialogue. So as we mentioned last time, one of the big things that we intend to be using data log for is implementing CRDTs. And one CRDT, for example, that shows up basically everywhere is RGA, replicated growable array, for representing sequences and text documents and lists and so on. It's a fairly complex CRDT, and the data log implementation for it makes use of quite a few features of data logger compared to other CRDTs, including negation and aggregation, which are sources of non-monotonicity, which add complications to the way that we have been using data log to really simplify the construction of these CRDTs. So some of this work has been thinking about what the extensions to delete reader have looked like in order to efficiently work with these sources of non-monotonicity. In particular, there's a very large 2018 paper titled Incremental View Maintenance Revisited that basically goes through delete archive and finds a lot of these sources of inefficiencies in these sorts of use cases that we're dealing with and proposes a few suggestions for dealing with them. So there's still some work to be done in terms of actually empirically testing out some of these ideas and seeing how they impact real use cases with things like RGA. But that's where my attention is right now and where it's going to continue to be for the next couple of days or so. And then once that's out of the way, really it's just the nitty-gritty details that we need to figure out in terms of how we're like what the actual data structure is going to look like for these facts within the backing star, like IPFS, for example, exactly what the properties of the end-to-end encryption are that we would like, and how we would like to handle the like the key agreement and key rotation and so on, so that we're able to provide similar properties that we've been able to with the web native file system, but under this much more structured database model that we are working with here with Dialog. That was a very high level look at kind of where our attention has been, but is there anything that stands out to you, Brooklyn, that's worth diving into more?
Well, let me define a few of those terms for people that didn't come to the distributed systems reading group on Tuesday. So monotonic writes. So this is when you have something that's just purely inflationary. So you're only adding information. You're not going back and deleting or invalidating, retracting data, things like that. So the really classic one is you have a counter and you're just throwing more counts into the counter. You never have to go back and overwrite something. So it actually can be extremely efficient. You're just throwing data into it. If you need to, you have a collaborative text document, it's deleting stuff, or writing to a certain point, and you have to insert a bunch of data in the middle, or you're merging two graphs together, and part of the reconciliation algorithm there is going to drop one of the two branches, and maybe that's the branch that you used. Then you have to go and go back and replay portions of history, basically. And that is way more expensive than just throwing data into this incremental view. So that's some of the stuff about the delete redrive, or DRED, D-R-E-D, DRED algorithm. I was chatting with somebody who does a lot of data log yesterday, who mentioned that DRED is everybody's favorite at first, but then it turns out that it not only does it a little bit overestimate how much you need to get rid of, but it can a lot overestimate. And the complexity then becomes, well, how do you get it as close as possible? We have some open questions or some theories about well, if we know that most of the data we're going to work with is directed acyclic graphs, DAGs, are there ways, and specifically for CRDT-like use cases, can we be smarter with that information so that we get really good, can we do better than DRED in a not general case then by clamping things down? The paper Quinn mentioned also basically takes DRED and also one, the name of the algorithm escapes me right now, and one other algorithm, and says, hey, look, if we do use these two together, we can actually also get much better performance as well. And this is mainly useful not for a cold start, right? But for, we're doing some live data in an application. We're typing into a collaborative document, or we have a mutable register, and we're updating information about, I don't know, people's travel itinerary because they're in Spain or something, right? And we want that to all happen relatively quickly without having a 5-second delay in the middle if there's a large database. So a lot of that is mainly, well, not a lot of that, is entirely about performance on that end. The encryption stuff and even the access control. So we've had a couple conversations in the past month after the last information dump on the last call, where the access control that we're thinking about for this is completely flipped from something like the web native file system, where there you have multiple writers into a single data structure, and you have to access control who's allowed to write into here. And for and really in that case, it's for good reason. Right? It's like heavily heavily read optimized. Right? This is heavily write optimized, and so we're thinking of it as, in scare quotes, millions of tiny databases where every browser, every context, every key has its own small data store. And then you can take a bunch of those and stick them together and then run queries over that. So how exactly we're going to do things like key management rotation, do we make it self-healing, have perfect forward security, all of that stuff is an open question because we want it to be set-like, not stream-like. But maybe the access control there then needs to be stream-like. So we're not totally certain. So let's see, getting some questions here in the chat. What do concepts correspond to? Marc-Antoine, could you?
Yeah, when you say each key, each concept will have its own little database. What is that unit of knowledge? Like one subject in RDF terms, one agent?
One agent.
One agent, thank you.
Yeah. So it's the entire data structure is it gets confusing talking about authenticated data structures. So we're going to call this an authorized data structure because it'll come with a certificate and a signature saying like, yeah, I actually wrote to this thing, right? And then that will be per key. And each of those has unlimited ability to write into that. And every other agent then pulls the sources that it cares about. One of the ways we've been thinking about encryption is it's a lot like having a network partition or latency. And so whether or not you're excluding a writer because you believe that they're, say, Byzantine, or they're encrypted, or you're just not interested in the data, it's kind of the same, like from the reconciliation, it's kind of the same situation.
Just to go back a second, Mark, having an individual database for each agent is really where we're taking advantage of the set semantics here for data log facts, because all of these different sets can just be unioned together in any order. By giving each writer its own database, we are basically offloading that reconciliation problem entirely to, or not offloading it, like basically mitigating it entirely and not needing to deal with the problem of concurrent writes at all here.
I totally approve of this approach.
Awesome.
What about multiple devices?
Yeah, each device is its own agent.
Yeah, this is something we've talked about a little bit, and there's still some details to be worked out here, but one of the approaches that we have considered is being able to store in like a config file within your web native SDK, within your web native file system, for example, almost like a list of sources that are associated with the agents that you have delegated your, in our case, your UCAN to, so that you can use that list to seed your discovery of these databases essentially. But then within data log, subscribe to additional data sources if there's, for example, another agent entirely not associated with your DID that you would like to pull data from.
Yeah, so there's two things there that I got a little bit blended. One is you need to be able to host this data somewhere, right? And so there is a version where you just say, well, this is ephemeral. It's only going to be online while I'm online. Too bad. There's another version where we attach this to backed up online storage. And in our case, that makes sense to stick this inside of the file system. Separately is which sources do I want to read from? And that has nothing to do with access control. That's entirely about, it's a pull-based model rather than a push-based model, which has been, we definitely will have to think about the UX around because that has been tripping people up. Even thinking about it like conceptually has been confusing. But like I mean, once people wrap their head around it, it's pretty straightforward, but also like, well, what are the metaphors? How do we describe this? How do we say, well, actually read from these things? Do we make it first class or just bake it directly into facts of like, yeah, and I also depend on this one here. We're using a lot of this stuff from, just because Peter's on this call, we're using a lot of the stuff from Martin's Byzantine fault tolerance CRDT paper. We were working on similar stuff, where every fact is content addressed, and therefore you may depend on something that's not in your store, for example. So you may then need to pull in from another source as a dependency. Yeah, follow subscribe language. Yeah, exactly. That's how we think about it already. In fact, we have some of those terms in Web Native already, kind of laying the groundwork for these sorts of things. But yeah, exactly. It's like subscribe to these sources, almost like an RSS feed or social media. It's kind of how we've
been subscribed to what we've been using internally most.
Yeah.
But you'll want to distinguish people you're subscribing to from people you're subscribing you and trust. Yes. I mean, and actually there'll be many, many layers of trust. This can get extremely interesting in terms of what's the truth status of a fact. It's in a way what I'm calling in my own research a social truth status. Right? Mm-hmm. Who believes in it? How much? Is it something that someone is considering? Or I think this has to be explicit.
Mm-hmm. Yeah, so in our use case, we don't need that as much because we're not trying to do, say, a social agreement or something. It's right. If we later decide, well, this data source is bad, it's a liar, we can rip it out and recompute, and everything should continue to work.
You can also capture that entirely within the data log view too, because these facts have problems associated with them. And so within your view, for example, you can filter out or annotate different facts as being untrusted or so on based on where they're coming from. But that's not something that we need to bake into the raw protocol or database layers.
Yeah, we have assertions and retractions basically in there. So if we think about the set semantics that are on the bottom, it's really saying, here's our assertion set and here's our retraction set. And you shouldn't believe these ones. Even if you have a causal dependency on it, this is a bad fact. Don't use this in the final derivation. Or if it is there, right, like you're going to need to adjust your view for that.
Can you talk a little bit about the kinds of software that you're imagining building? Because I'm having a hard time forming an opinion about the design without understanding its context.
Mm-hmm. Yeah, absolutely. So the core use case is local first web applications, and both in a all the classic local first stuff, right? Totally offline. I'm just writing my own stuff, or I'm with a small group of peers, but also so that we can do things like.
Are these chat apps or text editors? Is this circuit boards? Is it CAD?
All of the above.
So then you have a lot of, if a change is, there's a lot of dependencies and the magnitude of changes can be quite small. So if you have a whole content address for each keystroke, that I can tell you firsthand, this does not scale very well in either space, memory, or performance. Mm-hmm. And vice versa, right? If you have, if you have a long string and you don't have dependency information and you're well, I don't trust this person anymore. It's well, this data object was created by that agent. It's necessary for part of the schema, but we don't trust the agent anymore. If you get into a lot of really complicated resolution situations.
Mm-hmm. Yeah, absolutely. So the last one there, right? If we retract that fact, it's similar to us saying, well, we never saw it in the first place, or it's behind encryption, right? So how exactly we handle encryption is still, so we have some theories essentially where you have to have a public node and then some encrypted data hanging off of it. But we can always go down to the public node and say, well, here's where the the provenance hangs off of, right?
So all existing CRDTs are based around something at least akin to vector clocks or like total history dependency. I don't think this is necessarily true, but it is factually the case. And if you want to go to a softer model of dependency, so you don't have to throw out everything after removing a Byzantine or misbehaving actor for whatever reason, you're going to be off-piste, and like that's fun and exciting, but I just want to flag that as like a real significant model risk in terms of like understanding convergence and like object ID assignment, and like what does it mean for one person to not trust a source but then everybody else still does, and how do you propagate that, and then like here there be dragons, I guess would be my comment.
Yeah, so we're throwing out single system image as a trade-off, just to be explicit about that. So if you and I have have the same data, we can interpret it completely differently.
Yes,
and we can agree that we're going to use the same view function, but we don't have to.
And this extends even beyond interpreting the same data in the same way to interpreting the same data in different ways. And one concrete example that we've discussed is having different interpretations of data that represents some underlying CRDT to, for example, take a register CRDT and prioritize your own rights to that register so that in your local view, you will see your rights, but in someone else's view, they will see theirs.
Yeah, I mean, these are interesting capabilities. The reason I have been reluctant to explore this perspective, and I know the Cabal folk, I had a great conversation about how it was basically like politically problematic to impose convergence, which I thought was a really interesting social perspective on the problem. But I think it's very hard pragmatically to write software which is collaborative when you can't actually talk about a thing. And like if you and I are looking at the same document and we're using like human language to discuss it, it's nice if there's a high degree of probability that we're seeing the same thing, or have some user experience which allows us to get to the same thing, which becomes very hard if then any application can basically define any kind of policy. It's like, what are I guess I'm pushing back on this idea that like, is this freedom valuable, or does it actually just create a whole rat's nest of new problems that will make writing software very hard?
So it depends on the use case. Right.
Well,
so
yeah, this is why I was touching at the like, well, what's this for? And you're like, well, it's for everything. And I'm like, well, but specifically.
Yeah. So if we say that we have the same data store and the same view function, you can also context address the view function, right? Or at least hash it to make sure that we're using the same wasm blob. Then we're going to get the same end result, right? This is the whole CRDT convergence property. And for a single application, let's say that we're doing collaborative drawing, right? We probably don't want to prioritize our own rights or reinterpret that DAG as a set on one of the replicas. And we want to say we're in this one view. Where this reinterpretation becomes interesting is we have different applications that are pulling data from overlapping sources. So that they can, just like how Cambria tries to reinterpret data for different versions or even different forks of the software, we're saying it's the same thing of, well, I want to treat it like this, or I want to treat it like that. And I should still be able to write back in, and we'll leave it to the reader to decide what they want to expose to the user, essentially. So instead of going into something really structured, document like what Cambria does, and then doing translations with lenses across that, we essentially say everything is deconstructed into this, as Marc-Antoine calls it, a fact soup. And then we will pull structure out of that as needed and skip the translation
You might
part.
There's a talk by Roland Kuhn at Jay on the Beach where he talked about, CRDTs are the wrong thing. What you want is actually a like distributed state machines with apologies, in the sense of like, the promises, guesses, and apologies, the memories, guesses, and apologies. And like you just do your best with what you have and then reconcile later, and it's all just events in the state machine. feels closer to your model, and even if it's not, it might be, you might enjoy the talk just for like the extra context.
Yeah, what was the, sorry, at which event was this?
It was at Jay on the Beach. I don't know if the talk is posted yet. Let me see if I can find it.
Okay.
This is something that is touched upon in some of the other research that we've been really inspired by as part of the Boom project at Berkeley, with Bloom and Calm and Daedalus and so on. And the Bloom language is another data log-based language for defining views over these like monotonic fat soups, essentially. And the big thing that Bloom gives you is static analysis to determine the pieces of your program that are logically non-monotonic, not so that you can work around those technically somehow, but so that you can recognize that that is basically a coordination point where you may need to bring humans in to apologize for getting something wrong or for reconciling those mistakes and so on. And I think recognizing that that is inevitable is something that's going to be very important for these applications. What we want to do, though, is minimize the cases where that is required. And you asked about use cases for this a couple moments ago. And personally, actually, one of the pieces that resonated most with me was Jeff Litt's Merge What You Can, Fork What You Can't, where he talks about this idea of digital gardens in local first applications, where you have personal media libraries and like personal data repositories that you are sharing between different views and so on. And that has been a mental model that I've been really holding on to when I think about where tools like this are going to be useful.
Yeah. And, also to bring it back to, this is research, and there be dragons. Oh, there definitely be dragons here. It's entirely possible that this whole thing doesn't work, right? And that we'll have to go back to the drawing board and reimagine parts of it. But where we've been playing with this idea so far, it's actually yielded really interesting results. And even for things like, so one of the problems that we had when building the web native file system that everyone asked us essentially was, well, how would you build the Twitter fire hose with this? It's like, well, you can't, right? Because there's no single place where you can put things.
It's bad, the world doesn't need it, let's not have any more.
Yeah, but there's a discovery problem, right? Yeah. What if I want to discover data that isn't within, 2 hops of my friends of friends, right? How do I find out about messages that were sent to me? Essentially, how would we even replicate email in this model, right? I need to have some discovery layer. And one option in this world is, okay, well, we have encrypted payloads and we can gossip it between different hubs, essentially. So I think it
was kind of the scuttlebutt model, right?
Yeah, scuttlebutt. I believe Blue Sky's posts, I see Daniel on the call, also had some stuff like this in it as well. When you have models like that, you tend to like semi-centralize, right? Like here are the hubs, but you're never limited to them. So that's a trade-off that we're totally comfortable with. But keeping it totally set-like means that we don't reveal a ton of information about the structure of these things, not even who it's necessarily going to, because it's still always this pull model. And you may want to pull and decrypt a bunch of facts and then read them in a particular application. So there's all kinds of interesting stuff that happens around the encryption layer, but that then opens up all of these questions about, how do you work with data that you can only partially view when you have causal dependencies with content addresses, right? All of these things. So that gets hairy, obviously. So, and so actually here, let me, because I've had this sitting on the side here for a little bit. We have our list of open questions. My God, Zoom has so many windows. And some of them aren't even visible in the preview. Quinn, do you have?
Yeah, I've got it.
Yeah, okay, thanks.
That's private. So
that's private. Can you screen share?
Oh, screen share. All right.
Yeah.
Discord line.
There we go.
So it's a very rough list, and a lot of the stuff in here is working out the details around exactly what we need to support from the initial version of the data log. And there's more features listed than I expect us to want. There's a lot of really interesting work that's been done even in the past couple of months about supporting first order like lattice-based types within data log, for example, that I don't think we need for a V1, but have very obvious connections to some of the work that we're doing here. But beyond that, a lot of the remaining unknowns have to do with exactly how this stuff is going to be stored and encoded within IPFS, for example. Brooklyn has mentioned partial data for CRDTs. This is something that we have thought a lot about, and we have a lot of diagrams that we've written down. And now, more than answering whether it is possible to support partial data, the question is to what extent that is actually useful, and we want to kind of support as a first-class use case to expand on this.
Just that there's data that you know exists through dependency graph, but that you don't have.
Yeah, exactly. So concrete example would be, let's say you have a to-do application and the list of to-dos is represented as a list CRDT, but some of the items within that list might be encrypted. Is it still useful, encrypted with keys that you don't have? Is it still useful to be able to share that list with people who may not have access to the keys to decrypt all the items within the list? And to what extent do we want to, and are we able to do things like preserve the ordering of the elements within that list without leaking their contents? And what sorts of knobs and dials do we want to expose for doing that sort of thing within kind of the CRDT standard library, as I've been thinking about it.
Yeah. The other part there is, so yeah, there's encryption, but encryption is equivalent to there being, say, latency, right? Or some inability to pull, partition and any of these things, right? So when you have something like a vector clock, it's really, a vector clock under certain assumptions. So we have a mutable register, and we only really need to keep the latest updates, right? For that, however the graph resolves. If you're using direct causal links, you can't jump a bunch of updates. You have to actually look at all of the intermediate ones. And so there's some questions there around, well, how can we handle this if one of the providers isn't available? Do we just have fragments of graphs that can't reconcile suddenly, right? We don't know where they attach, where their causal link is anymore. So there's some questions around that. Do we have multiple links? Do we, look at some of the Bloom clock stuff?
I built a bunch of these apps, and I can tell you from long experience that peer-to-peer stuff always fails and downloading goes awry. But this never happens to me with email, because when you get an email, you either have it or you don't, along with all its attachments. I talk a lot about data as place versus data as thing. I think that there's something really deeply wrong with what we have been doing at Ink and Switch, which is using these kinds of, content. So content-based links are bad because they don't update as change happens, and then you have to do link propagation, which then creates new links, which causes endless cycles, and this is a big problem. That's already used back in the day, or hypercores today. But that's a whole other thread. But there's this idea that it is possible for you to have references to data you don't have, strikes me as we should engineer that capability away, right? So if you're going to send somebody a document, every piece of the document should come together as one thing. So you either have it or you don't. And the more I have worked on this stuff, the more I've realized that not starting from that fundamental assumption I mean, like I think you do, obviously there are links between web pages exist, but like you never open up like an app you've downloaded on your phone that's finished downloading and then it's like, oh, actually we need to download the rest of the app. You're like, no, I have the app, right? It's here. So I think it's really good to focus on bundling up dependencies into larger aggregates at like a fundamental distribution layer that are larger than the individual CRDTs and where you do like a spidering and aggregation step. I have not built this yet, but I'm increasingly convinced that I'm wrong to be using links in the first place. And all of our early prototypes used, effectively content-ish addressed hash links to handle data. So you'd send somebody a link. And I now feel like the much better way to give somebody access to a CRDT is to send them the current state of the CRDT, right? Like the difference is instead of pasting a link into a Discord, you would drop an attachment into Discord. You drag it out of the app and drop it, or you'd send somebody an email, or you'd stick it on a thumb drive, or the app itself would have some functionality to do this. And that data, we should be pushing the whole thing and not just a link to the thing as like a first order.
But I think that's the exact point of content addressing that versus location addressing.
No, but
so I really like your drag and drop idea, and I think it's a totally unexplored space, and I love how TiddlyWiki does that. And I'm trying to get other people to possibly just like hack around with that. But the content addressing is, I think, some of those interesting things exactly where this content address does exist. And whether or not you can access it is a separate thing.
And so like the problem is you build apps this way and then you have to do all this extra work to make them usable because you have to build all of these like user experience affordances like sync progress bars and like, little green dots to show that you finished downloading and things like this. And if you just bundle up the whole thing and like make these like much sharper boundaries around aggregations, then that a lot of
almost like archives of content addresses.
I see where you're going with this.
Which is in fact a primitive that we have.
So I actually may be interesting to touch on really briefly. The other thing that we're working on in the reactor is car sync. So being able to push bundles of IPLD graphs around in what is essentially a content address tar file over HTTP for federated use cases. So not have to rely on the DHT, being able to take a whole bunch of data, package it together and do it in one trip, and doing graph synchronization in very, very few trips, like orders of magnitude less than what you have to deal with BitSwap. So that's something that we're hoping to actually get out in a spec like relatively soon, like days to 2 weeks sort of thing. And that doesn't solve everything that Peter's talking about here at all, right? But it's in the same direction.
Mm-hmm. Going to what Peter was talking about though, the example that I always have in mind when we talk about this feature is like Google Calendar, for example, where you have a ton of different even calendars that you are working with. You have your personal calendar, the one you share with your significant other, your work calendar, and so on. And these events are shared with different people. And in a pull-based model, I'm not exactly sure what it looks like to aggregate all of these different subsets of calendars together and send those directly to someone, especially when you're not exactly sure what the network topology looks like. And I'm curious to know whether the way that you're moving towards thinking about these ideas fits into that use case, or if I'm misunderstanding you a little bit here. Since under our world, those different events are just encrypted with different keys, and the people who have those keys will see those events when they look at their calendar. It's not a case of you preemptively needing to bundle up all of the different like permutations and subsets of events that all the different audiences may have access to.
I think to zoom out, right, like the goal is to have people use the things and to make them intelligible. And so in everything that we do, there's always this trade-off between like increasing capability and flexibility and making things legible to like a developer audience and, you know, people that exist today so that they'll actually adopt these things. And so I spend much more of my time worrying about how far we are from what people understand and how much, you know, how we can reduce the like abstraction costs and the mental skew than about whether we can support things. Because right now I feel like the existing capabilities that are out there in things on the market are substantially better than what people are already doing, and yet adoption is negligible and understanding is non-existent. So I'm much more on the like, how can, you know, what is the mental model that people are going to use? What is, I was talking to one of the authors of Orleans, which is Microsoft like scale out thing. And they have a beautiful programming model where it's like you write what feels like single node imperative code with a couple of library includes, and then you get like a massive scalar distributed system. Like, how do they do that? Well, they do some clever stuff behind the scenes.
I think the mental model here actually, so you mentioned a whole list of things. You know, I think the like real-time collaborative editing Google Docs clone thing is an interesting target to keep in mind. I think chat apps are like, yeah, you can do a demo chat app with this, but really just use Matrix and WebRTC, or like, you know, pick that as a transport protocol kind of thing like that. The stack that we're moving down from is you are a front-end developer. You do not have to become a full stack developer. So you build your front-end React app and you're like, I gotta like put in a database. Great.
Yeah.
And that's, so
right.
that's even the starting point.
Like people who are coming from that world don't have sophisticated opinions about like cryptography and keys and key management.
Correct. Which is exactly why you have a data log interface, which is like, well, I don't really know SQL either. I don't really know SQL either. So this is a friendly-ish language is our current hypothesis. You could, of course, put an SQL or GraphQL on top of this as well.
Want to be clear, we're not expecting to ship data log to people as the high level.
Yeah. At all, right? So we're going to put a DSL on top of that. There will be no : happening at all. It'll be a builder syntax of some kind, probably inspired by GraphQL and LINQ.
Yeah, and so I'm kind of in the like, I'm much more in the Yagni like, don't share a to-do list that has encrypted items. Like how do you solve the problem if some of the items are encrypted? I just don't do that. Like don't support it in the APIs. Don't encourage it in the documentation. Don't think about how to solve it. Just make it hard to do. And then if people try and do it, then you can tell them not to. And if they insist on doing it, then you can watch how they figure it out. Like
I'm not sure that we want to tell people not to do that, though. At least personally, one of the applications that I'm most excited about a system like this is being able to take all of these different organization tools that I use and consolidate them into one view that allows me to like delegate access to pieces of that data to other people.
So and even above that, an explicit goal is that we run stuff that is both private and public out on various transports that are content addressed. And so you're exactly right that the developer shouldn't have to worry about all these things. They need to decide, you know what, I want this entire to-do list to be private other than people I share it with. And in their only mode is various permissioned use cases. And that publishing, making something public might be something that they do. This is roughly what we see with a lot of current tools for thought tools. Everything is private by default. And then there's this publishing mode that bakes it into another thing. I'm mixing and matching kind of metaphors here a little bit because this is like, no, we're just putting around data soup databases that are on this very broad substrate. And you can choose to have public items and you can have private ones. I think you're absolutely right that the dynamics of here's a to-do list where some things on the list I don't have permission to is a very application specific use case, and is a harder case that has a bunch of like UI affordances needed too.
I mean, directly before this call, I was sharing my personal calendar with my work calendar on Google Apps, and I only wanted it to see for your busy, right? I don't want it to have access to everything else. And keeping those two in sync as completely different structures is pretty treacherous, right? So it's when Quinn says, I want people to be able to see parts, but not all of it, and give permissions, like there's this whole gradient of what people can see, and that creating linked data there is helpful.
I guess it's hard for me to envision this from the conceptual discussion without actually having a developer experience in front of me. So I will, I guess I've spoken my piece, and it sounds like you feel confident you have answers to these problems, or that they're non-problems, and that's great. So I will look forward to seeing it.
I definitely wouldn't say that they're non-problems.
Or that we have answers.
Yeah. I largely agree with everything you're saying here. And I don't think that the concepts that we want to be showing developers when they get started with a tool like this are cryptography and elliptic curves and things like that. That's not where we want to jump into these discussions with them. But as implementers, that's where the sorts of higher level features that we would like to expose from them are going to be constructed from. And that's mostly where some of this early work is coming from. Not thinking about what we want to tell the developers, but thinking about what is even possible to express with the tools that we are working with.
Could I bring... Oh, go ahead.
Please.
I have a totally different type of question to ask. And it's that of, in a way, you keep speaking about views and constructing views. Mm-hmm. And it totally aligns with what I'm trying to do. And I'm wondering, for you, are schemas at the view level or at the data level? And how do you handle contradictions, basically? Is contradiction a property of the view, which I think it is for me, and I'm curious how you view that.
It's at the level it's at the level of the view. There's no inherent schema. Everything's
right.
A data soup until you structure it somehow. So even if there's causal links between data and you want to interpret that as just as a set, right? You just want to count the number of events. That's the thing you can do, right? Yeah. Or you decide, well, I only want, it's a data log, right? I only want to look at these attributes and not any of the other ones. And in my view, I'm going to write a query that looks at just those things. That's the thing you can do. And even for the, say, CRDT reconciliation, when you look at the different species of shape of CRDT, including the history, right? Sometimes you need to grab the entire graph. Sometimes you only want the, the
result of certain computations,
right? Yeah, exactly. Some of them are fanned out because there's no causal link between them. It's just a collection of things, like a counter is a classic one, where it's just to say, well, this is the same entity, right? So the view is the part where we're essentially pushing all of that into the view, including the schema.
Makes perfect sense to me. Makes perfect. That's what I wanted to check. Thank you. Though of course it is a lot of punting, but it makes again sense to me.
Yeah, so we've done like sort of proof of concept data log queries or views that was like, well, given that we would have data that looks like this, how would you build that? And then we've actually written the :- version of this is how that would, this is what that would look like.
Yeah, kind of the three main species, as we've been calling them, of CRDTs that we have been noticing as we've experimented with these sorts of views is the fan out approach with things like counters. The chain, as I've been calling it, which are things like last writer wins register, where you have some large DAG, but then you are essentially materializing over some chain within that DAG that gives you the history for some lineage of writes. And then more AST style DAGs, like you see with something like RGA.
And then I have another question. Can there be, like in the monotonic data soup, does it make sense to have non-monotonic snapshots of the view, right? Which, okay, this is the computed at point X, so we can exchange that instead of exchanging the data soup if we're synchronizing and saying we can combine those views because we have a lattice operator on this view. Is that something? Yeah.
So this is where some of the current research into where something like delete rederive fits into this model is focused right now, because a lot of the complications with incremental view maintenance come in when you have non-monotonicity, either negation or aggregation. And one of the big approaches in general for dealing with non-monotonicity and data log is this idea of stratification, where you have some data log program, you do dependency analysis of it to figure out the like slices of the program that depend on earlier pieces. And then that gives you, it basically turns a non-monotonic data log program into a sequence of smaller monotonic programs that are taking input from the earlier steps. And the 2018 paper that extends delete rederive, one of the approaches that they take is to basically do a stratified delete rederive, where rather than rematerializing the delta for the entire view at each step, you're instead rematerializing specific stratifications based on which rules have had inputs that have changed.
Yeah, so there's that. And then also, I think you were asking the materialized view, can we just exchange those as well?
Sometimes, yeah.
Yeah, and so yes, there's, I can't find the graph, I was looking for it briefly now, but because if you annotate that with its provenance, and basically say like, hey, that you should be able to find a Merkle root over here that contains everything that created this piece of data. Oh, thanks, Boris. Then you can have, so your data store, right, your knowledge base plus the view is isomorphic to this materialized view, right? But once you have that provenance information, you can go, and so if we think about this as moving across, adding things, and then view to go down, as soon as you have the provenance, you can get back up into the facts. And once you're in facts, you can now take subsets, roll back and forward, do all the bitemporal stuff, all of those things. And so as long as your materialized view is mergeable somehow, then you don't have to worry about the whole database underneath it. And you can get very, very fast things while still maintaining the ability to get back into this data log world. Yeah, because it's just combining the two that went into it, right?
So if you have like a under-resourced device that doesn't want to hold a ton of this data soup and doesn't have the compute power to put together these views, you can offload that to some larger node, like an indexing server or a data server or something like that, get the materialized view, but then still have enough information to add new facts into it.
Yes. So part of this idea when we're looking at these these different species is to say, what's the cutoff point for what we could pull onto a low power device so it can do it locally? And I mean, this version where we're offloading to say an indexer or something, that's actually like the easy case because you're saying, I trust them. They should be able to see everything. We're in a trusted setup now. Doing that in a untrusted way is essentially impossible until you start getting into things like snarks, right? Which is a little early still for us, but it's
yeah, because your proofs that they're doing it correctly without snarks are essentially getting all of the datums that make up the view, right?
Correct. Yeah. So we want to be able to take just the subset of the graph that we actually need to work with. And that's part of the idea of saying, well, we have all these different data sources. Which ones do I actually want to pull right now? And even then, which part of the history do I actually need? And we can calculate that statically, like purely syntactically ahead of time and grab just like the latest bit. The hard part there is if now you get an update that's way down here in the graph, well, now you have to pull all of this. And so that's part of the thinking about like, well, if you have something like a classic vector clock, you can skip a lot of this intermediate stuff, right? But we don't have that. We have direct causal links. And so that's a trade-off currently that we're making, where one of the approaches that we're looking at is doing graph contraction. So all of these are versions of DAGs. Like 100% of them are versions of DAGs, right? And if you have something that has more structure to it, that's not just purely fanned out, then you can say, well, from this point to this point, I can contract that and say, well, this is what made that up, and have an again, an isomorphism between these two graphs that say, well, I'm going to take all of the paths, bring them down to points, and all of the divergences and convergences, now everything between them are just points, and really reduce the amount of stuff, provenance information that we need to have in between. So that doesn't work totally offline. You have to go out and grab data to bring it locally. So to get things totally locally, we've put some thought into that. If you want to push something off to a server, yeah, totally, you can do that too.
And this is also too early to say that this is going to be the approach that we are going to be taking, but many data log implementations store provenance for facts using binary decision diagrams, which are really compact encodings of basically the Boolean formulas that represent the visibility of that fact, so that you can determine whether or not a fact is derivable using the database that you have by just evaluating this logical formula, essentially. I bring this up both because of the provenance stuff Brooklyn was talking about, and because you were talking about low-powered devices, because this gives you a way to essentially prune out the database that you have locally to only contain the facts that are computable using data you have access to. One of the large issues with sharing snapshots and such under this model are that both because of encryption and because of the subsetting that we're dealing with between different data sources, it's very likely, I think, for most use cases that you will not have access to all of the facts that a snapshot was computed from. Yeah. And so you need some way of reconciling that with the data that you do have.
Yeah, so there's two places for that, right? One is, or two scenarios for that, right? One is you're offline, you're on a plane, you don't have Wi-Fi, you have to do things locally, right? B is a low-powered Android device, right? And we're increasingly concerned about this use case because so many developers work on their fancy laptops, right? And don't realize, oh, most people don't have multiple terabytes of storage sitting under their desk, right? And finding ways to grab just the bits of data that we actually need to work with, really, really, really important. Yeah, and making it battery efficient, not always talking to a full DHT, working within some cluster, all of that stuff, and using technologies that actually work in all of these are network bound, right? How do we make the network more efficient? And that's doesn't really exist today in the space. So
just one very quickly, you were speaking about small nodes, Daniel, and big nodes. This has been done in the RDF world. I was trying to find the name of the project. I will find it at some point, but they did micro RDF servers where you could basically give just the simplest queries like subject predicate, predicate object, or object predicate. And then they had something that could compose those to answer arbitrary Sparkle queries. So that was a very interesting decomposition of the logic requirements.
Yeah, that is really, I'd be really interested in that link because we're working on something very similar to that.
Oh, okay. I'll try to find it. It was a German university research, but I'm still looking.
Mm-hmm.
And it sounds maybe not that different from some of the aggregation use cases that we're looking at as well. The twist, of course, being that we're also dealing with encrypted data so that this node might not be able to actually see what it's working on. And so you may be able to give it enough information to know that it needs to select those things, but it can't actually run the full computation. One of the nice things about data log is, or for certain subsets of data log queries, is that you can run partial queries over data, bring the results together, and then filter over that. And you'll get the right thing. So. Awesome. we're about 5 minutes over here. Does anybody have a final burning question or thought or comment that they'd like to make before we wrap this one up and head to the after party? No? Okay, awesome. Well, thank you so much, everyone, for coming to the second one of these. I will turn off the video now, but hopefully for anyone watching this on video later, hopefully you'll visit us for the next one.